chemical reactions of the alcohols and phenols. Alcohols and phenols. So what are the major important points under this topic? So how they participate in chemical reactions. So because of ROH or AROH, we can write aryl or aromatic ring attached with hydroxyl group. So here common thing is hydroxyl group, right? So this is responsible for the reactions. So how it will be? So if you see either this one, I mean ROX, alkyl group and aryl group. So in both the side chains, I can say the hydrocarbon chain, which is attached to alkyl group, is common thing is carbon, COH. But this carbon is an alkyl carbon. But here, this carbon is an aryl carbon. Right. So, aryl carbon means it belongs to aromatic ring. It belongs to aromatic ring, meaning that it is a part of the aromatic ring. Suppose I can write like this. This carbon, which is attached to the hydroxyl group, is part of the aromatic ring. Like this, right? So this is all. But here, it is attached to an alkyl carbon. So hydrocarbon chain, normal hydrocarbon chain like this. So whatever it may be, here if you observe, in alkyl group, the carbon is attached to O and oxygen is attached to H. Here also carbon ROH I can write here. Here AROH I can write. In both the cases, what is happening? Suppose in this case, as well as in this case, what we are observing, I am saying. So here, there is a bond between the carbon to which alkyl group is attached, between carbon and oxygen, right? One bond. As well as oxygen and hydrogen. This is one bond, prominent bond, where alkyl group is attached to the carbon. Another one is where oxygen is attached to the hydrogen, right? Here, this bond as well as this bond, I can say like this. So like this, here also, same thing, right? And write like this, OOH. Here also, same type of bonds you can see, OH, COH. Here, this bond as well as this one. So here, two prominent bonds are observed between C and O and in between O and H. So during the chemical reactions, it may break down, it may undergo the cleavage of this bond or this bond or this bond or this bond. If it is, phenols, this will be common in both the things. Cleavage of CO bond or cleavage of oxygen hydrogen bond. So both are common in alcohols as well as phenols, we can say, right? These are phenols, we can say phenols. General alcohol, these are alcohols. So here, alcohols and phenols, I can say alcohols, can act as, especially alcohols, I can say, alcohols acts as Nucleophiles. Nucleophiles. What are nucleophiles generally? Phile means which is attracted towards. So it loves. Phile means phile, loving anta. So this is the meaning of phile. So it is loving towards nucleo. Nucleo means positive charge or nucleus. What is the charge of the nucleus? Positive. That's why you will write like this. Nucleus loving species is called nucleophile. So what is nucleus loving species? Positive charged positive charge attracting species. I mean the species which will move towards positive charge, meaning that it will have more negative charge. That is the meaning, right? So alcohols acts as nucleophiles. When alcohols acts as nucleophiles, alcohols we know ROH, we are saying, no doubt. When they are behaving as nucleophiles, ROH, alcohols as nucleophiles. When they behave as nucleophiles. So whenever the bond between O and H is broken down, whenever the bond between O and H is broken down, so they act as nucleophiles. I'll show you like that. Suppose this is a nucleophilic center, carbocation, I can say. This is a nucleophilic center, one of the nucleophilic center you can write. What will happen here? On the oxygen, you will have lone pair of electrons. When this bond is broken, what will happen? Electron density will increase on the oxygen. So electron density increases means it will become more negative, more negative. So if it is more negative, it is having more negative charge. Electron density is more. Electron density will become more. Becomes more. So what will happen? Automatically, it will try to search for a positive charge. So positive charge center. So positive charge center. So that is that we can show in this form. So it will go and try to bind with the carbocation. So what will happen then? So it will form R O H. So this I am writing the intermediate form because of the for showing the lone pair of electrons. This is the intermediate form, I can say. So finally, what will happen? So from intermediate state, what will happen? R O C plus H plus. So H plus. So why H plus? Already I told you this bond will break. So whenever the bond between oxygen and hydrogen is broken down, then during that situation, the alcohol acts as a nucleophile. So because of increase in the density of the electron. So increase in the density of the negative charge. So it will act as a nucleophile. It will be attracted towards the positive charge. That is the reason. So second thing, when they will act as an electrophile. So when alcohols act as electrophiles, I can write ROH as electrophile. So here we can have a doubt. See, it is already oxygen is having two lone pair of electrons, right? Even in alcoholic state. So then how it is possible it will act as electrophile? So again, it is behind more negative charge. So until otherwise it will get a positive charge, it cannot attract towards the negative charge, right? How it will happen? So this is happening because of protonation of alcohols. You can say protonation of alcohols, and majorly we should not forget that one. So ROH means I can write like this COH. So because of the breakage of or cleavage of bond between carbon and oxygen. So this is alkyl group. So in alkyl group, so OH is attached to carbon only, right? So this is, you can write like R. So one more thing. Or simply you can remove this bond also, because that indicates the remaining carbons. Okay. So because of the cleavage of carbon oxygen bond, alcohols acts as electrophiles. How we are going to see that one? So how it will happen? Because of protonation of alcohols, they attain a positive charge and they will be attracted towards the negatively charged species. That's why they love towards moving towards the electron-rich region because of accumulation of positive charge on the center. Okay, so how it will happen? So first, protonated alcohols. So protonated alcohols. Protonation means addition of hydrogen is, H plus proton. Addition of proton is called protonation. Protonated alcohols. Alcohols acts as electrophiles. How will see? How protonation will happen? Suppose RCH2OH is the alcohol, right? So if it undergoes protonation, if it is added with H plus ion, H plus ion is called proton, right? So then what will happen? It will be protonated. CH2 OH2 plus. Why? So one lone pair is completely, because H plus means no electron in hydrogen ion, right? No electron in this hydrogen atom. H plus means the single electron what is present in the hydrogen atom, that is also not there. That it means, right? So then what will happen? Among the two lone pair of electrons, what it has having on the on the surface of the oxygen atom, one will be completely donated to the H plus ion, the proton. So what will happen then? It will get it is completely donating, means that's why it will get positive charge, partial positive charge. That's why we will say protonation, we will say. Okay. So this, I will remove this one. So for your understanding, again, don't confuse. This is the reaction. So reason is this one. You understand? So it will completely gives a pair of electrons to that one. So it will form a dative bond, right? So it will attain a positive charge like this. So this is the protonated alcohol. Protonated alcohol. Understand? So this is. So how these protonated alcohols will attain the, will show the electrophilic nature? I will tell you. Okay. So then what will happen? So because of this protonation, so it will attain a positive charge, right? So it will look towards the electron-rich region. So if any negative ion is electron-rich ion comes forward, suppose Br minus, bromide ion, then what will happen? So it acts as electrophile. So how it will happen? I'll show you. OH2 plus, right? So what will happen then? So easily it can combine with this one, a negatively charged species, to form alkyl halide, right? So this is the, the nature of electrophilic nature of alcohol. So protonated alcohols generally acts as electrophiles. So that is what we have to see. So based on these two nature, so alcohols as nucleophiles and electrophiles. Electrophiles, right? So what is the reason for this one? Because of cleavage of OH bond. Correct? This is because of cleavage of OH bond. And what about this one? This is because of cleavage of CO bond, right? CO bond. So cleavage of CO bond. So basically what we will do here means, so we'll classify the chemical reactions based on the cleavage of OH bond. One. Second category, cleavage of CO bond, right? That's the thing. So you can see that one. So first type of category, right? First one is reactions because of cleavage of OH bond. Cleavage of OH bond. So whenever OH bond is broken, usually what will happen? H plus will come out, right? So any substance, any chemical species which releases H plus ion, that generally will be called as acidic in nature, right? Acidic in nature. Understand? So that will be called as an acid. So then automatically, so cleavage of OH bond will refers to the acidity of alcohols, right? Acidity of alcohols as well as phenols also. There also OH is there, right? So where even in the case of AROH, and the bond between O and H, if it is broken, then we can call it as acidic. Even phenols are acidic in that sense, right? So because they are also having the thing. Okay, that's how you have to see. 1 second. So here H plus ion is responsible for the acidic nature, right? So whenever OH bond is broken down, H plus is released. Generally, that indicates the acidic nature of a particular chemical species. Here also, cleavage of OH in alcohols represents its acidic nature. So how, that is shown by the alcohols means, so because of two reactions. So one is, I can say A, I can write like this, A. Reaction with metals. Reaction with metals. So what metals? Alkali metals and alkaline earth metals, and even I can say aluminum group metals. So I can write with the reaction with metals. So it proves that they are acidic in nature. Second one is release of H plus ion, right? Release of H plus ion. So how fast they release the H plus ion into the medium. That indicates the acidic nature of alcohol. So second one is acidity of alcohols. Acidity of alcohol. So these are the two important things through which they prove that, because of cleavage of OH bond, they are acidic in nature. They are acidic in nature. So acidity of alcohols and phenols, both will show these reactions. So reaction with metals, even that will be shown by phenols also. Acidity of alcohols also is shown by the phenols also. So I mean acidity is also shown by the phenol because they are also having OH bond, right? Cleavage of O and H will generate H plus, and that indicates the thing. So we'll see the general reactions of reaction with metals of alcohols. So A, I'll write react, how they will react. So you can generally, I told you, alcohols react with sodium, potassium, I mean alkaline, and even calcium like that. Even aluminium, I told you. So they will react with alcohols. So ROH. So here, what important thing is, here you will get a sodium alkoxide or metallic alkoxide plus hydrogen gas. This is very, very important. So that's why we will take 2 atoms of sodium always, or 2 atoms of, I mean, we will balance the stoichiometry, simply balance the reaction for balancing reaction. So 2RONA, metallic alkoxide plus hydrogen gas. This is very, very important. So any case, if you take this sodium alkoxide, sodium alkoxide. So this is hydrogen gas. Hydrogen gas. So whenever alcohols react with metals, reaction of alcohols with metals, reaction with metals, metals generate always hydrogen gas. Okay. So this is how it will happen. Sodium alkoxide. Even you can take higher alcohols. I mean substituted alcohols. I can say primary, secondary, tertiary. Any type of alcohol you can take. They can create such type of alkoxides as well as the metallic alkoxides and hydrogen gas. So for example, you can take a tertiary alcohol. So with aluminum, we can write tertiary alcohol. Carbon is attached to 3 carbons. The alcoholic carbon is attached to 3 carbons. So I can write a tertiary alcohol like this, right? OH plus 2 molecules of aluminum. Aluminum charges, we know aluminum is plus 3, right? 3 plus charge. So in that case, we have to take 2 aluminum atoms to balance the reaction. So it will be like this. Aluminum tet butoxide, you can say tertiary butoxide. 2 molecules of CH3, CO, CH3, CH3. So it all will come here. Aluminum plus H2 gas. H2 gas. That also 3 molecules of H2 gas. So here, what I am saying is, I can run one more time. So for your understanding how it will. So aluminum is having 3 plus charge. 3 plus charge means here 1 plus, here 1 plus, or here 1 plus. So suppose if I take a 1 tertiary alcohol, so how it will react? So how it will react means, so oxygen is negative charge, that is attached to 3 carbons, right? Here, here, here. This is CH3. This is CH3. Oh, sorry, 1 second. And 1 second, 1 second. Not an oxygen, right? Sorry. So this is oxygen, right? So we can write oxygen like this. This is attached to alcoholic carbon. So this is a tertiary carbon. CH3, CH3, CH3. This is neutralized by 1 charge, 1 negative charge, right? This is positive charge. So another one is like this again. O minus, I can write like this. This is attached to a tertiary carbon, right? CH3, CH3. So again here O will be there, negative charge. It is attached to alkyl carbon. I mean the tertiary carbon, I can say. This is the tertiary carbon, right? CH3, 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 right? So this is the charge. This is oxygen, oxygen negative charge, oxygen negative charge, I can say. So aluminum tertiary butoxide, tet butoxide, tertiary butoxide. So how we need, I think, to balance the reaction, we need two types of aluminum like this. Each aluminum will be attached to three alkoxide. So this is tertiary alkoxide. Tertiary alkoxide. Each one is called tertiary butyl alkoxide. Tet butyl or tet butoxide, you can say tet butoxide. Each one is tet butoxide. Tet butoxide or tertiary butyl oxide or tet butoxide. Simple. So now you understand. Such formations will happen twice. Another aluminum also will show the same thing. That's why we have written two such type of structures attached with aluminum. Understand? Two such type of structures attached with aluminum. Means two aluminum will be there. So here we have written, right, as a coefficient, right? Understand? So 2 means aluminum also 2. This tet butoxide is also twice, like that. Twice means again it will be of this structure. It will be of this structure. Understand? So meaning that 3 tet butoxides attached to one aluminum. These type of structures I mean to say. Understand? These type of structures like this. These type of structures. So that we have written here in this form. I can say, I'll write one second. One second. These type of structures we have written 2. This is the meaning here. 2 means 2 tet butoxide attached to aluminum means this entire structure is twice repeated here. Understand now? That is the meaning of this particular structure. So here also hydrogen is released and metallic, here metal is aluminum instead of sodium. So you can write with potassium also, no issue. Okay. So, but you have to remember always hydrogen gas is released and metallic oxide. So this is aluminum tertiary butoxide, TRT butoxide.